Hey, David.
Good evening.
We'll see if other people show up.
So I went through the framework patch set, and as expected, since you're on like revision 7 of it at this point, there's really not much to comment on. You know,
Okay.
um, the only thing is, and I understand why it's this way, and it's completely fine. It's this way but in the device initialization code that you have for it, um, some of the functions that you use say that you should use a different function for the deallocation of it, but everything you have there makes sense, because you broke out the initialization into a separate function in a certain way. You ended up using um
Are you talking about
so
the like constructor destructor stuff that the TSM drivers use to initialize things, or is it something else?
yeah, that basically. If you give me one sec, I'll go back to that patch set and take a look.
Okay.
Um, where was it?
Good day, everyone.
Hey, Lexi.
Yeah, yeah, like device initialize says I forget what the exact text is in the for the function in the kernel code, but you're supposed to use a certain um, deinitializing function when you use device initialize. Like device, it was something about device unregister does extra work based on whether it was device
Oh,
register
okay.
or device initialize.
Right.
And it makes sense why you do everything here, especially with the returning a non the pointer that doesn't get freed in scope and everything like that. But yeah, it's just the kernel code, I believe, suggests that if you use device register, you're supposed to use device unregister because it's
Right.
supposed.
Yeah. They're supposed to be paired.
Yeah,
Yeah.
but you're
Yeah.
using device initialize instead, which is fine. Fine,
Yeah. Yeah. Yeah.
it works perfectly fine. But that was the only thing in the entire patch set that
Well, if
yeah
we're down to those issues, then I feel better. I feel
yeah
better.
yeah
um.
I didn't see anything.
Okay. Okay.
I have
No,
no
thanks.
stake in the naming conversation, so yeah.
You can pick any color as long as it's black, yeah. But the uh but yeah, like today uh we could do go around to opens. I mean, it's we're kind of in a I mean, thanks for taking a look at that. Um we're kind of in for me, we're kind of in a quiet period until the merge window closes. I do want to I know I said I was going to I was going to respin the TSM series and send it out, but like we're this close to RC1 coming out, so might as well just wait until it's out and then rebase the tree on that and send out the that version. I'm hoping it's the end, but if it's not, we can keep iterating on it. But the goal would be if it looks good to everybody on this call, basically, um, I would queue it for I would queue it to start soaking in Linux next, and people can start basing branches on it. Um, I think in terms of if we wanted to get some stuff upstream for 619, like so, I think host side IDE SPDM establishment. I think we're pretty much done with that. I feel like the next thing is going to be lock and accept flow on the guest side, and that still has some open questions and and need to get through it. So I don't think that's probably going to be make 619. Maybe if we can get through it, but that's going to be next. But I think last time we were talking about how do we want to upstream some of these things. Um, I think it's like if you so there's gonna be I'm gonna run the staging branch and a next branch. So next is just gonna be the core bits, hopefully stable commits that other people can base their branches on. I do want to pull AMD and ARM and Intel all into the staging tree for integration testing, but in terms of going upstream, I'm assuming that you're going to want to post your patches and get them merged by your architecture maintainers or whoever, like Boris for AMD and I don't know, Robin or whoever or Caitlin or whatever, whoever going to do on the ARM64 side. I mean, if those maintainers want me to carry it, I'm okay with that too. But I'm assuming that it's those they probably just want to say, okay, give us a stable commit for the core stuff, and then we'll take the patches through our trees. So however those maintainers want to do it, just let me know. I'm up for carrying it in tsm.git if that's what people want. But I'm kind of looking forward to putting some of this stuff to bed.
I'm a
Elon,
bit lost. So
okay.
you'll have next tree and staging tree, and we use what when?
Okay,
Staging.
so staging. I want to run it like everybody's latest work in progress upstream stuff. We just merged it together to make sure that we're not stepping on each other's toes, and it all works together. And we can kind of maybe put it through one big CI. But in terms of what's going into Linux next, my guess is that x86 people want to take the SEV stuff. ARM people want to take the CCA stuff, and I'm okay with that. So basically, you tell me what you want to do. Like, do you want me to take everything?
Yeah. So
fine.
if we decide to go through Boris's tree, then we won't be using your next branch, right?
So you won't be using. Well, so my next branch will have the PCI core bits because Bjorn active. So I would be okay if Boris wants to start a topic branch and pull in the basically base that topic branch on the stable next branch that I have, then he can, and everybody can all the arcs can pull that into their topic branches.
Okay.
And
Understood.
Yeah.
Yeah.
So staging
and
will be like
this-
TIP, whatever tree, which is pre-based every day, course pushed every day.
Yep.
This kind of stuff.
Yeah.
And it will be automatically built. Is it like we can give you a branch which you can use to kind of pre-build staging based on whatever we are pushing latest, because the spec keeps changing and we probably have things on the architecture side which needs to be rewritten. So so the staging, okay, that's nice. Yeah, that's really good, because having one tree to see all the three architecture work together is always useful. I now have to kind of switch. I haven't got anything on the Intel side. I keep switching to Alex's tree to kind of see what Alex is doing. So having it in one tree is always good.
Yeah, which is good, and yeah, and I think also we might see where we like, hey, we actually have a conflict.
Yeah,
those would be interesting.
absolutely.
And the other reason we need it, especially for the Intel side, we're still stuck behind the fact that our TSM needs virtualization turned on, VMX turned on, and Sean wants to kick that support out of KVM. But until we do that, we're kind of stuck behind. So we might have some work in progress patches to refactor that, and those aren't upstream ready. So all that kind of mess also might live in staging. So I'm okay if staging is not
good.
Super, it's not super clean,
very nice.
but it's an integration branch. Like kind of like our this is our best foot forward across three architectures. Like this is the current state of consensus. Doesn't mean that you guys can't have consensus diverging stuff in your own local trees. That's fine too. I just want to have somewhere where it's like, hey, look, here's everybody together, and it builds, and it actually kind of runs on somebody's platform, that kind of thing.
So how did it go with early virtualization enablement?
Okay, so Sean hated it. The stuff we did with the always on VMX, and so I'm dropping that. I have a replacement patch that moves it to a module. The thing is, so we talked about this at the Puck meeting. He has a long running project to try to be able to run two versions of the KVM modules at the same time. And so for that effort, he had refactored a bunch of like common stuff out of the KVM module, but it also right now is encumbered with a lot of Google internal stuff, and so basically we're like, either he finds the time to untangle it and post it, and we base on his stuff, or we come in for the Intel side and say, here's the start at moving it, starting from scratch. Here's how we would move VMX on out and see if he goes with that. So I actually pinged him just before this meeting to say, hey, I have a shot at moving that out. Do you want to go with that, or do you want to stick with your thing? And so we'll see what he says. But that's kind of where we're stuck on kind of putting that stuff into the next tree. So maybe 619 might just be AMD and ARM just for that reason, just depending on how things play out.
Okay, I see. Because I asked Tom, and he was like, "Yeah, we can do this early enablement. It's not AMD who will, object. It's KVM folks."
Hi Dan.
Hey.
When you have refactored the VMX songs that you put into the module, I'm not sure if so. With this approach, does that still affect MD?
No, yeah, and so that was the other thing, is it makes it less. It doesn't touch anything well, it touches one common thing, but only the emergency disable SVM hook, but it doesn't change any timings with AMD. Everything still happens at the same time, and so it's not as invasive as Shin's patches. So I think it's much less invasive. I mean AMD SVM can follow the same pattern and move SVM to their own module, but it's not. But right now I think we can just do VMX SVM whenever they want to, and then any other CPU can do the same thing.
Yeah. So do you think
I'm pretty sure SVM is enabled by CCP driver now.
Oh, CCP needs SVM turned on?
I think KVM will talk to CCP to enable SVM in the PSP or hardware. It's not like KVM itself. I need to double check. There was some work, moving these bits between KVM and CCP.
But this is for SNP. Like you need to turn on a special version of SE. You need to turn a special version of SEV that is managed by the CCP, not the CPU. Or I don't know. But yeah, I mean,
it's definitely for SNP and SEB.
Okay.
For SVM as well, it might be so.
Okay.
Anyway, you have another solution.
Cool. Okay. I mean, well, we'll see. Like, yeah, like right now, really, the game is either Sean releases either Sean shows his cards or he lets me play my cards. But that's the game. That's the game of poker we're playing right now.
Okay. So now with your new implementation, is it okay that we could have TDX connect stuff in your staging tree? I assume that it will not conflict. It will not impact MD anymore. Is it?
Right. Yeah. It won't impact AMD anymore. We can move stuff into staging, and I think so. If Sean says, like the worst case scenario is Sean says, no, don't do your thing, and no, I'm not ready with my thing, then I would put my thing in the staging and say like, hey, this is just here to enable us to make progress. We're not going to go upstream with it, but yeah, that should unblock us to allow TDX Connect to go into staging tree.
Yeah. Yes.
Yeah. So I wanted Alexi and Anish to know that Yulun found a bug in the two PCI TSM 0. Like it was the same kind of. It was related to the bug you found, Alexi. Where like, hey, shouldn't you walk from the device back to the TSM? And I did that, but then the actual TSM that we do the conversion on is also not the right device. So I fixed that up. I was surprised that my unit test was not crashing. I just must have gotten lucky. But I'll fix that in the next posting, in the V7 posting.
You didn't
if
enumerate the VF, is it?
Let's see, let me. I'll share my screen so people know exactly what I'm talking about here.
Yeah, I mean, in your sample driver, you didn't produce a VF instance, so.
Oh, that's right. You're right. Yeah. So
Yeah.
you're right. The only device I ever test is the actual device itself. So it'll never fail. So that's
Yeah,
yeah,
yes.
okay. That makes sense.
that's true for my testing too. Okay, that's just
Oh, okay. Yeah. So maybe we're all probably, yeah, we're all not using real VFs yet. So that's why it's all these working.
yeah.
I do.
But Alex, I remember that you mentioned that your trust device must be on a VF, is it?
It's what I pass through. Yes.
Yeah.
I'm not exactly sure what is fixed right now. So if I could see a small diff of dense V7 versus V6, or when we post it, I will just do diff myself and see the difference. Because I have a bunch of small patches on top of dense patches, but neither of them is fixing exactly a bug.
So
maybe it does.
Can you see this? The change is basically this was the old version and this is the new version. So if you called this on a VF, you would be looking at garbage here. So that's the only change. But yeah, so good catch on that one. But yeah, but I so go over here and so yeah, so here's a new PCI TSM. We got no ops in here, no more owner. It's just devs. I like to look at this. It's all devs, and maybe in the TDI context. So I'm okay with this. That'll be this is the going once, going twice final auction on this data structure. But yeah, so that's really it.
I had a related question with respect to guest request. So we have, so I'm doing the complete rewrite with the new updated spec, right? So there are some changes with the new spec that come from on the CCS side. And there is a need to do device validation as an MMIO validation, and that ends up in VMM. And that I'm planning to use guest request. So I have this slight confusion regarding what should be a new TSM op versus what should be a guest request, right? So if I look at the PCI ops, it's either info or change state. So for things like, can you map the device? Yeah, can you map the device? Can you make sure this guest real address and this PA is indeed, guest bars and things like that? Do we use guest request? I vaguely remember Alexis saying he uses that for guest request. He uses guest request for that.
For validate?
Yeah, MMIO validate or device memory validate. I mean, that's ARM's terminology, but I'm pretty sure there is something else on the.
We have a validate too, right? Like do you use guest requests for that validate too?
For MMIO validate, I think that's on TDX it is not a guest request because TDX has some direct communication between the guest and the TDX module use TDG call.
It's a TDG call, not a TDI call. Okay.
Yeah.
So it's more or less similar. So the guest makes a request to the TDX, to validate. That actually cause an exit into the host. Um, um, and then the host cannot, I mean, when I say exit into the host, it comes in the KVM. And since I need a reference to the PCI device, PF0 and TDI, I take a exit to VMM, and that exit ends up as an IOCTL to IOMMUFD. Now from there, I am not sure, should I go to the guest request IOCTL, or should we do like a new one, like bind, unbind kind of a thing?
I think you should go through the guest request, because actually host does not care about the
Yeah.
MMIO validation things. Host when on bind, host already assumes that it's the MMIOs are the management are all handed over to the guest side. Host will not touch these private memory anymore. And if there's some substates that guest need to manage for the MMR, it could be go through the guest request.
Yeah, which brings me to the other questions. Right now we have only two PCI op, right? One is get info and change state. So should we add, in which PCI op bucket does it fall? Should we be adding a new one?
Well, I think it's change state, but it's a change state that's
okay.
within scope. Within
That's
scope
what I did. That's what I did.
right?
Okay.
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 But that brings up another point. Is I like Yulun's idea that guest request is for things that the kernel shouldn't care about. But right now we're using guest request to go to the run state, and I think we should probably do an operation for that. We should have a PCI. We should have a and we talked about this on Discord, but I think having the run state should not be a guest request, right, Elon?
My idea is that from host point of view, the log state and the guest, the run state are of the same.
I mean, a bind. We're gonna have bind, and then we're gonna have, and then they're going to be guest requests for like not for security material too, right? And then the actual, then accept. And accept is, but accept turns into run on the host side.
Yeah. My idea is that the TDSP log state and the TDSP run state has no, they are the same from the host point of view. Hosts don't have to distinguish these two states. Because when you have locked the device, you didn't host don't touch the device.
And when you run the device, the host can't touch the device.
Yeah. That makes no difference from host point of view.
To that extent,
it's the host which tells TSM to switch the state, right? Check locked, run. The host has to know to make the right call to the PSP. In our case,
the host has to do the operation, but it's basically passing through parameters of the kernel. Like the host cares, the kernel doesn't care. Kernel's like, I don't know what you're doing. I did the lock thing. I did all the VFIO changes to like make sure now that I'm going to emulate bus master and these kind of things. But after that point, it's just the guest passing stuff through the kernel to say, hey PSP or hey TSM, switch to run state. I think that's the point. So it's host does the work, but the host doesn't care what's in the payload.
My only worry is, will guest request ends up being this big multiplexer which takes in so everything. Right now I have a guest request used for asking the device to send in new measurements interface report, and ask that's one. Then I have also a guest request used for returning to the guest the measurements because the measurement things, whatever device sends get cached in the host for good reason, and then it gets sent back through another guest request. So those are all in get info. Then I use guest request for transition to run state. Now I'm going to use guest request for MMIO validate. So that's not a concern.
It feels crowded.
Yeah. And there is one guest request. There is one other reason why guest request usage where we do have this identifier which the guest is using, and we the firmware, as in the RMM, needs the host maps that identifier to an object ID. And so when the firmware gets this ID, we call it VDEV ID, which is nothing but the guest device identifier, which is the RID which the guest is using. Now, I take a VM exit and comes it all the way back to VMM. I could actually handle it in the kernel itself because it just needs to find the PCI object, basically the physical address of some data structure. But then it comes all the, because we don't want to do that in KVM exit path because it's kind of like a layering violation. I take all the way exit, comes to guest request.
No, yeah. I mean, like the problem of when do we need to exit back to QMute?
Yeah,
Or
whenever I
the
exit
VM
back to VMM,
to
yeah.
come back in, yeah, to come back in versus do it directly. I
And whenever I exit to VMM, I am using guest request for almost all plumbing now.
yeah. Like yeah, I think it's it comes back to what is KVM willing to accept in terms of talking to devices and doing anything with devices versus punting everything to outside back to VFIO kind of thing, and have it be tied to the VFIO object. I mean, yeah, because I had the same reaction to use some of these things. Like, wait, you're telling me I gotta get this thing in the TSM driver, in like the whatever, yeah, the TSM code, package it up, kick it back out to user space to call back into the TSM code to do the thing, and um, but yeah, but that doesn't make it consistent with KVM. Doesn't do anything with devices.
Yeah.
I mean, so like, but are you saying that, like, I do expect that guest request is going to have, four, like a handful of things that are pretty much kind of the catch-all for all the different corner cases of things that guests need to pass through to the host that not every vendor is going to agree about. I think I think that's okay. I mean, do you expect that there's at any point in time there's going to be, oh, I wish we had formalized this into an operation because actually
Yeah.
the bulk of this is something that ARM and AMD and Intel all want to do, kind of thing.
Yeah, maybe we can start with guest request, and once we have staging, we can see what is the commonality, and then probably abstract it into like a operations, right? And
Yeah,
so
that
right
might be
now, as a
easier.
first,
Yeah.
yeah, right now, first cut, I will put everything in guest request, whatever I want, and then we can take a look. Yeah.
I think I can look. I mean, this has been my problem with this project is at any given point in time, understanding what everybody else is doing and where the commonalities are. Like I have a mental map in my head, but I think it gets easier once we have a staging tree. We can actually see it and grep for it in the same thing, and know that this is, oh yeah, we know this tree actually builds and runs for everybody's use cases, and so this is a good thing to research. But also, yeah, I think we also have time because that's also why I think like 619 for the base TDIF stuff, or base IDE stuff, is more settled, and yeah, and this discussion about what does the guest side look like, what does the guest request look like, how do these things actually play out across the three architectures, that might need another kernel cycle to mature. Okay.
So question about guest requests on ARM. Say in my case, it's 2 guest requests. One is from guest to host, the other one from host to PSP. Right? First one is GHCP protocol. The second one is PSP protocol. And I thought on ARM you jump from guest to your secure firmware, right?
Yes. So the easiest way to view that, Alexei, is secure firmware is the hypervisor for all practical purpose. So the guest is actually running on top of the secure firmware. So if I am making I can directly enter into the firmware. There is calls for that RSIs, and I can go to so-called KVM. There is call for support for that called RHIs, realm host interface and realm service interface. So I don't use guest requests for any of these. Now, once I end up in VMM, how do I come to the Coco driver? That is where I end up using the guest request ioctls on the IOMMUFD side.
Well, it's not exactly guest request in this case, right?
Yeah, yeah.
The guest already reached what it wanted. So
yeah. And in most cases, when I'm coming, it is there are few cases where I come to VMM and then I want to make a device communication, and the KVM cannot issue the device communication. It has to be issued by the firmware or the RMM. So we make a realm RMI call, which is special in that you could call it guest request, right? You are doing that RMI call on behalf of the guest, so that we do a communication with the device, because the DOE mailbox, everything is owned by the host. So the firmware cannot write to the DOE mailbox. So it will want host to ask the firmware, what do you want to communicate? Collect that, write it to the DOE, get the response, put it back, and we call it device communication. Did it make sense?
again, not guest request.
Yeah.
Okay, because I mean now I understand why I feel it's like crowded guest request thing, because if it's not even guest request.
In a way, yeah, we could, yeah.
But it is. But why does it have to be on the same? Like the only reason we have guest request is because we need a general way to get back from internal VFIO calls back to the TSM driver. Like and then we need to have this like, because the VFIO might need to independently do things like unbind and these kind of things. But if it's purely,
that's exactly what. That's the reason why I'm using guest request. So it's actually, for me, guest request callback is used to connect the VFIO or the IOMMUFD piece with the TSM backend driver.
Okay, so because where I was going with this, and maybe it's not the case. It's not like this is it could be like a private ioctl that's only for ARM, and you don't need to actually. You could just call directly into your TSM driver with its own ioctl. You wouldn't need actually to go through. You wouldn't need to go through a VFIO ioctl to get back to the TSM core layer to get back to the TSM driver.
For this, we go via IOMMUFD because it has all the bits, like guest BDFN, host BDFN, and other things. It just holds all these bits in one place. That's the only driver which knows all of it.
If you had your own private ioctl, it would have to rebuild all the context anyway, so there's no point. Basically.
Yeah.
Okay. Yeah. No. Yeah.
The way.
Go ahead.
Quick recap how I do this in AMD. So my guests don't specifically ask for lock and accept. I have 3 guest requests. One is get info. The other one enable MMIO. Third one is enable DMA. Right? So when I do first one and it goes to KVM unconditionally goes to QEMU. KVM doesn't handle any of that. Then QEMU will issue a series of ioctls to IOMMUFD. do bind, if it's needed. If it's like first time we getting and forward, then do bind, get it to lock state, get all these blobs, put it in guest memory, then do RMP update if it's at Mayo, if it's enable MMIO. It's all in QEMU. There is like a function 100 lines long or 150 lines. And it's using IOMMUFD as a proxy to TSM to PSP eventually. And then my TCP driver for PSP, it will look what's going on now. We're enabling DMA. Then now we're ready to go to run state. So there is this route from guest,
Which is
KVM to QEMU to IOMMUFD to CCP to PSP.
Yeah, which is more or less true on ARM too. So for you, all these calls that is ending up in QEMU comes to IOMMUFD and ends up using the guest request callback IOCTL, right? If I get that correct.
Yes.
So that's what I'm saying. So that's why I felt it crowded. So my question was, should it be an independent
but
IOCTL at the IOMMUFD side?
So my guest request is actually guest request. It's 3 things which guest asks for PSP. And I send these 3 things via this
which is also,
guest request hook.
Yeah.
So that
yeah,
feels
but then
natural
QEMU
and not crowded.
So the QEMU is doing things on behalf of guest request, right? So like the guest request is it's more or less the same. Like in ARM, we are asking for validating an MMIO. So it will come to VMM. The VMM will make a guest request. Guest request will end up in the TSM callback driver, TSM driver. I'm calling it TSM backend driver or TSM architecture driver. And that will actually issue calls to the firmware or in your case, PSPs to get it done, right? If I get that correct. Did I make sense?
That makes sense to me. I don't know if it makes sense to Lexi, but yeah.
So you exit to QEMU, and then you call what? IOMMUFD with guest request.
IOMMUFD with guest request, exactly.
Right.
And that will come to the TSM backend driver, and the TSM backend driver does whatever needs to be done with PSP or RMM.
But you don't need the guest request to affect the state of any kernel side object. It's all pass through, right?
Yes, that's true. None of the objects are. We don't touch the state of the host. Okay, I think that's a good distinction for me to kind of keep. If we are changing any host object, don't do it as a guest request, right? That's what we are saying.
That sounds If the kernel, if we got this kernel thing, the kernel needs to know exactly the semantics of what's happening. If it's pass through, it's pass through.
So when the guest makes this guest request, which ends up in what's that, RMM?
Yeah.
That's in TSM. It will unconditionally exit to KVM pretty much, and then expect KVM eventually, or QEMU or IOMMUFD, make this call to RMM again when it will do actual job. And then you return via all this again.
Yeah, exactly.
QEMU, RMM, and then you go back to guest.
Yeah, exactly.
Yeah.
Okay. Fair enough. Then it's similar.
Yeah.
Good.
We can do a whiteboarding during December, definitely.
Yeah, it'd be, definitely. Go ahead.
I have unrelated question when we finish with this. We finished with this?
I think so.
Yep.
Well, nothing more from me, Anish.
Yeah, nothing from me. Yeah.
Right. So the question I got last week was, say you run a machine in the cloud, you have a big device with a bunch of VFs, and then something bad happens to the physical function of the device.
Mm-hmm.
Right? So you need to do function level reset or PCI reset, whatever. Physical function gets reset, VFs all gone. But you don't want to reboot the whole machine because it's cloud and customers and all that. So you want to recover, I don't know, reload module, issue reset, IDE state will be gone, and you want to trigger this connect stuff, right? To get it back. And then hot plug each VF to each VM if you want to. But the point is, host should not reboot and should not require reboot. And guests should keep running guests because there may be some unsafe work, We don't want just kill guests.
Yeah.
Have you thought of any automated IDE reconnect?
So
Has anyone asked that
well,
before?
people have asked, and Jason and I have gone back and forth a little bit about this, but the resolution has kind of been like punt this to the end. But I think this kind of error recovery is something we're going to want to do. I think it really is going to, like, my initial thoughts are like that we probably want to treat this as an AER error and teach the PCI core about how to recover IDE links as just another kind of we have other link down conditions and we recover from them. I think the hard part about this is we don't have a very good framework for injecting AER into guests, especially because I think right now if the host AERs, right now QEMU just gives up. So I mean, on the one hand, I think we should should be fixed, and this is probably a good.
No, QEMU will give up if it's VF which received this error. But in our case, we will detect reset state of PF, hot unplug everything.
Oh, I see your thing.
Right? But the
problem
with the IDE remains.
Wait. Say that again. The problem is
with IDE. We want to reconnect before we reset physical function, and then we want to re-enable IDE on this physical function and create VFs again, hot plug them, and all that without rebooting the host, right?
Right. No, that makes sense. I mean, but like so actually, so you're right. So like we don't. I mean, but the VS will still go to TDIS error state, right? Because.
Oh yeah.
But you say you want to. But automation on the host can unbind cleanup. I mean, actually, it can't unbind because the SPDM session goes down too, right?
Right.
Like how do you destroy something when the SPDM session is down? I guess you just tell.
I cannot think of anything but unplug.
Unplug. Yeah. So this event unplugs all the devices. Something reconnects it and then plugs them back in and tries to tell the guest like, oh, your device went away, but it's back now. But you fully expect to have to go through the full lock and accept flow again.
But the question was, what will trigger IDE connect on the host in such case? Will we write a small daemon in systemd which will listen on CSFS connect file, and if it went from TSM0 to empty line, then we'll just trigger connect, or what?
I think what I would like to see is that once we have a connect state, that until you tell it to disconnect, that any error that drops the link restores the link. So that like just like AER today, we don't have user space get involved in PCI AER cleanup. Like we get a protocol error, we get a fatal error, we do recovery, whatever recovery is, reset and bring the link back up. And so I think IDE should be the same. IDE should link recover automatically. But when it does recover, that's going to be when automation needs to kick in to be like, okay, let me go recreate VFs, reassign, rebind, re-notify guests. But like the actual, I think the IDE recovery is probably the easy part. The hard part is how do you automate VF restoration and replugging? Because that's a whole bunch of user space work that needs to be kicked off.
True. Well, no, that we won't be solving in this project. We'll let distros to figure it out.
Well, yeah. I think we let distros figure figure out that. So I think as long as we have like a link goes down, I don't know if there's any kind of notification to user space today about AER events. They could just be like, oh, something happened. I need to do something. I do know that like when on some of the recovery, the kernel core will rebind the driver. User space will definitely see that, but this is probably not. We probably don't need to rebind the host driver. We probably just need to recover the IDE link.
I would think UDF would somehow detect these things.
So I mean, we might even make the policy in Linux just be that, especially because you guys were saying that on your platforms you should have enough IDE streams for everything in the system. Like this kind of Intel concept of, oh, there might be less IDE resources than there are devices. It might be an Intel only thing. But anyway, like if we know that a device can support IDE, why wouldn't we just always turn on IDE and like connect? Yeah, you can connect for the manual mode, but like should we just have a mode anyway that's auto connect and really all you use the sysfs for is for disconnecting if you need to in this mode. That all the things that's come up recently. Like, hey, do we actually need user space to take a step to turn an IDE? Like, it seems like a good thing that should be turned on all the time.
Well, but you also need to be able to support a mix of TVMs and non-TVMs, right? So there are certain there'll be certain virtual functions that aren't using IDE, right?
There'll be certain virtual functions that are not using IDE.
They keep working as usual until you accept them
Legacy.
in TCP. So you don't really care if IDE is enabled or not.
Yeah. Well, not even that, like just a legacy VM, right? The TDISP model allows you to have a series of TVMs running next to a legacy VM.
But having IDE enabled should not be a problem for any of those, right?
Yeah.
Yeah. I mean, yeah, because I mean, IDE is even before even any TVM is launched. Like you could run IDE without ever launching a TVM. But yeah, but once you do, whether the device gets assigned because you could turn on IDE and assign it to a legacy VM, and the device it wouldn't know the difference.
Yeah, because it won't send anything with TBIT 1. Everything with TBIT 0. Yeah. Good point.
But yeah, so that's
by the way,
that might be something.
How long does it take for you to get device connected? Because for me, to program all of it and the whole SPDM session establishment and keys and such takes, I don't know, 20-ish plus seconds on current machine, and the one which we got, better version takes seconds. Not one, but about 3-5.
How much of that is DSM time versus TSM time? Like it sounds like it's the device problem, not a
Device answers much quicker than PSP handles it.
Okay. But is that difference like in the number of DOE transfers, or?
No, you mean between two CPU generations?
Yeah. Oh, it's between two CPU generators. I thought it was between two different devices for the same platform.
No. I have two test devices. They behave about the same.
Oh, okay.
For this matter, it's CPU which behaves a bit different. But the newer CPU is much faster. But it's still like seconds. And if you have, say, 20 devices and you have 3 seconds for each device, your boot time of the host is increased by 1 minute.
I see what you're saying. You're saying like if we might want to be careful about automatically turning on IDE because we could make boot go way slower.
Yeah, maybe not like blazingly fast all the time.
Maybe that's the best idea. Yeah.
But I have the concern that in terms of this IDE encryption, it always related to a question that who should about the TCB that which entity should own the key. So if I'm not sure if it makes sense that we blindly hand over this IDE encryption into the TSM's TCB.
Wait, what do you mean? Like in this case, we're just automatically turning on the ID, so it's still the same TSM
Yeah,
generated keys, not native IDE.
yeah. So you always you hand the ID encrypted key to the TSM TCP, but I think maybe that's not always what the kernel wants. Is it? Because maybe it wants to establish some native ID or some other for other purpose.
Oh yeah, no, yeah. Like, and this is the question I have or the conversation I have with Lucas all the time. Like I think if the platform allows the kernel to pick the key, I can see somebody wanting to install their own keys. I don't um I don't see the value of that versus like just letting the TSM do it. The other contention is I think Intel is the only, like, because we were talking with Samuel on Discord because he's asking about, hey, this key P table, how does that work? And this is on Intel, we can switch an IOMMU mode from from secure mode to unsecure mode, and if you could actually manage ID yourself if you turn out on unsecure mode. I don't think any other platform on the planet does that. so I'm not sure Linux should. I'm not sure Linux should carry that support for native IDE because it doesn't. It would only be for a single vendor. Like right, like AMD doesn't let you do it your own keys, right? And ARM doesn't let you write a niche, Alexi. There's no way for the kernel to do its own key negotiation on these platforms with the root port. You have to go through
right
the
now,
TSM.
no. Yep.
Yeah.
But it all depends on how the host side ID encryptions. But I think that because we have the ID specification for PCI devices, that it means it is possible that we could have a root port that implements the full functionality of the ID specification, and the host could control this root port device to establish IDE.
I mean, it can, and that's what the Intel kind of definition does. But the PCI spec only defines kind of key management between like native PCI ports, like all the host bridge stuff. It always once you get to the host bridge, like PCI spec says, talk to your host vendor about how your host bridge works. And so yeah, so that's why this ACPI key table is an Intel specific thing and not like a PCI standard thing. There's no PCI standard way to program IDE keys in a root port.
Okay.
Is the problem. I mean, if there was, yeah, but I think that's the problem.
No, what do you mean? There is just exact same way as you program keys into device. You create another SPDM session to your root port and do all the same magic.
I mean, I guess
I'm pretty sure that's what Samuel does.
Samuel has. Oh, you can do native IDE on RISC-V. I thought he was saying you couldn't. Okay, maybe.
No, Samuel on RISC.
On RISC-V, yeah.
They have two SPDM sessions, one to root port and one to endpoint.
Oh, okay. So there's two platforms on the planet that can do IDE keys, native IDE.
Yep.
So yeah. So anyway, so like, yeah, question about whether we turn on automatically or not. I'm not against doing native IDE at some point, like, but yeah, I think we do the TSM thing. I think it'd be nice to model the native IDE as another TSM driver. It's a low-level kernel provided TSM driver that knows how to do IDE, but that's a project. That's like a 2027 project for me.
Has anybody asked for such support? Any customers?
I know of some people that want IDE before TDISP, and the thing I've been telling them is either either just wait until Linux can do TSM and use it and use your platform TSM, and that'll work for multiple vendors, or ask your platform BIOS to set up IDE before you hand it off to the OS. You don't need to wait for Linux to do it. Just turn on IDE before the OS boots, and that's what CXL is going to do anyway. Like the whole CXL TSP protocol is BIOS establishes IDE, BIOS maps the CXL, and basically tells you here's your secure memory, and you don't, and OS never needs to do a CXL SPDM session. So yeah, either do it with your TSM, do it pre-boot, and then I'm not sure we actually have anything left for native Linux to do IDE.
That's true.
So we'll see.
Cool. I like that.
I have some concern that I think maybe turning on the IDEs that and you will encrypt every TLP traffic. Is it a non-trivial overhead for the PCI communication?
It probably is overhead, not free, and increases latency. I think it's a question of if you're somebody who's deploying something in a point of presence, and you're worried about somebody putting an interposer on your cable or something like this, then maybe you're willing to pay that cost. And yeah, so I mean, I wouldn't think it would be something be on by default everywhere, but it would be an option that like you can set a kernel policy to turn it on because like because you want to prevent, like it's the same value proposition as total memory encryption that we have like on AMD and Intel. I think ARM has it too, right? So and it's really just to protect you from people stealing your DIM and getting the data off it or putting on an interposer there. So I think that there's some people that want that protection, though they're willing to pay the cost.
Yeah.
And some people want compliance, not security. They just want like oh, don't you know that somebody could still be spoofing this? It doesn't matter. Like it's encrypted, so the compliance people are happy with it, kind of thing. But yeah, no, yeah, you would definitely need to pay the cost for it. I don't think it's free.
Yeah. Because I'm thinking that if you need to pay the cost, that then you should not put it as a default option.
Not default everywhere, but you have the option to maybe not default, but like the option to turn it on at boot versus having to have users like. You can always get a new user space that knows how to do the connect and figure everything out, but it's kind of nice when you can just say, if I boot this kernel, I know, and I have an IDE device, it will do IDE, and you don't need to get a new user space.
But still, if you enable IDE by default, you only pay the small delay at boot time, but that's about it. After that point, if you don't run CVM and you don't accept devices, there is no encrypted traffic. It's real hard to force encrypted traffic.
Isn't that a platform policy? Like I thought some platforms allow T = 0 traffic over IDE and some don't. This only works if your platform sends T = 0 traffic over IDE. Like default stream kind of stuff. But
so if you enable IDE, all traffic becomes TLP with TBit and with TLP prefix, and either encrypted or not. And then some platforms it cannot be unencrypted.
No,
I'm not sure I follow.
No, like that you can send T = 0 traffic over encrypted. So the device encrypts it, puts it on a link, it gets to the root port and decrypts it.
I thought Tibet says if it's encrypted or not. No?
No. Tbit says if it's going to the is going to the TCP or not, but not encrypted or not. At least that's my understanding. Yeah, so like
that's true. Yeah.
Yeah.
So it kind of is an indication whether your TLPs are hitting a secure memory, protected memory kind of a thing.
Yeah.
But the TLP itself is always encrypted over the IDE.
So you can send with IDE you can send the only combination you can't do is you can't do T equals 1 in clear text, but you can set up IDE and send T equals 0 over clear text. You can send T equals 0 over encrypted, and you can send T equals 1 over encrypted.
Okay. Then okay, it's not free.
But yeah, but yeah, I'm glad we had time to talk about IDE because that means that we actually are in good shape on some of the base stuff, and we are ready for next week when RC1 lands. So
there is one question for me there. There was this feedback of using Fox device instead of platform device. One of the challenge I have with the TSM driver is how do I manage the auto loading of the TSM driver if the platform supports these features? And the Fox device.
Oh, sorry. Did you see my note? I actually
Oh,
I
no,
saw that.
I didn't see that.
I saw that thread. So we have this useful thing on x86, which is basically a module device table that loads based on a CPU ID.
Yeah, based on a CPU feature, right? Yeah,
Oh,
yeah,
CPU feature,
modules, yeah. So the problem is, it's on ARM, it's ELF cap, and I mean, yes, I could look at fixing that, extending that. More than that, it's not just the CPU feature that we are dependent on, right? We also need to have RMM firmware. The CPU itself may support the capability to run an RMM firmware, but the RMM firmware may not exist, or the firmware is not configured to run in an RMM fashion, right?
Do you have the concept of like simulated feature bits that you could like that's another thing in x86?
Yeah. So one thing I could do is if the CPU supports RME feature, then I load the driver, and the driver during the loading phase check for the presence of the correct firmware, and if not, just dev so that the driver probe routine returns
Yeah,
false.
that's another way to do it too.
Yeah. I was wondering whether we should look at, but then what I'm trying to get to is all the TSM class device parent will be the Fox device, right? That's what we are agreeing to. We want that as a requirement.
I mean,
Sys class TSM0 will be parented from where? From a platform device, or it's okay to be parented from anywhere?
I mean, on Intel, it'll be a faux device.
Fox.
On the I think I say faux, but Fox, but yeah, but
Okay.
Yeah, no, that will be on the host side. The TSM0 will be hosted by a faux device for Intel because we don't have another device. But Alexi is lucky because he has a nice PSP PCI device, a real device. But
Okay.
The rest of us probably just have faux devices.
Okay. And on the guest?
On the guest side, at least for TDX, we already went and did a miscellaneous stuff. So it's a module that autoloads based on CPU ID, and it creates a MISC device, and that's the only device we have. And so we put some more. We just are parenting things underneath that miscellaneous device, which is not great, but it's already there. Like if I had it to do over again, I would do a faux device on that side too.
Yeah, that's what I was trying to for ARM. There is a platform device right now on the guest side for TSM report and things like that. So I was trying to switch to Fox device, and then the problem was it was not auto loading. So yeah, I'll see if the CPU features works, or maybe I was just wondering whether I can make module device stable against a Fox device, and then
Module device. I mean, like, but you don't need faux device to have.
So the core will create the device, and there is a mode info module device table for the CSM TSM driver.
Mhm.
And because the core created the device, the mode probe will load, the UDEV mode probe will load this driver, and the driver knows the name of the device created in the core kernel, and then we parent it.
Yeah, yeah. I mean, but with the module device table for CPU ID, you don't need another. The module loads just because it sees the CPU.
Yeah, yeah. I'm not sure it's there on ARM based on it's based on ELF caps.
Okay.
So yeah, I'll take a look. So you are saying CPU features is probably the easiest to go. Yeah, I'll take a look.
I mean, that's what that's where at least we're doing on x86 or on
Okay.
Intel.
Okay.
Okay. Well, you guys have a good rest of your day. I'm gonna go put the kids to bed, and we will see you at the next one.
Yep.
Thanks everyone.
Hey,
Nice
thanks,
Thank you.
guys.
Cheers. Bye.
See you.
Thank you. Bye.